This is Emily. Emily is an adolescent. This is John. John is not an adolescent. Adolescence is a time when risky behaviors such as fast driving and substance use increase. But why? When assessed using surveys, adolescents are just as good as adults on tests of risk perception. But something interesting happens when you add the potential to win reward into the situation. Adolescents tend to approach reward faster and with less regard to the potential negative consequences, and less thought for other goals they might have. You know, Emily was on a diet until we tempted her with this cake. In gambling tasks, adolescents tend to show riskier behavior than adults, again approaching the potential reward with less regard to the potentially negative consequences. Sometimes this works out really well. Risky decisions sometimes pay off. And approaching potential reward is thought to be adaptive. It pushes adolescents into novel situations, like social situations with their peers, which gives them new experiences, helping them to develop new skills. In fact, this increased tendency to approach potential reward is seen across species during the adolescent period, and is thought to be evolutionarily adaptive as a way to avoid inbreeding. Sometimes, though, this risk-taking doesn't work out well. Looking at the brain can help unravel the mysteries about Emily's risk-taking and reward-seeking behavior. This part of the brain plays a role in what's sometimes called the impulsive system. When we see a cue signaling potential reward, activity in this region generates motivation to approach the source of potential reward. Our impulse is to go for the reward. But sometimes we need to stop this impulse to approach and take some time to weigh the pros and cons. This inhibiting and reasoning activity is largely undertaken by this part of the brain, sometimes called the reflective system. Sometimes the reflective system fails to do its job, and there can be lots of reasons for this. One is that it takes effort, and we don't always have the resources needed to inhibit an impulse or an action we know is not in line with our long-term goals. 2. If an impulse is really strong, if in the moment Emily's attention is drawn to a reward she desires, then it's harder for the reflective system to guide behavior to a different option. Failures to guide behaviors towards one's goals happen at all ages, but the adolescent brain is uniquely wired such that they are hypersensitive to reward. This makes them more susceptible to self-regulatory failures when stimuli signaling potential reward are present. Let's take a closer look at Emily's developing brain. We see prepubertal increases in grey matter densities, followed by postpubertal loss. The decrease is thought to result from a process called synaptic pruning, a process which enhances information processing, capacity, and speed. The developmental trajectory of grey matter reductions differs by brain regions, with brain areas associated with basic functions such as motor and sensory functions developing first, and areas involved in more complex functions, including the functions of the reflective system, maturing later. Changes in white matter also occur throughout adolescence. Myelination, the forming of an electrically insulating sheath around a neuron, underlines an increase in white matter volume, a process that aids the functional integration of widely distributed circuitry, such as those involved in the reflective and impulsive systems. Using brain imaging techniques, such as fMRI, we also see hyperactivity in the impulsive system of Emily's brain when she is exposed to cues signaling the availability of potential reward. So sometimes Emily can't help herself when she sees something cool, and you wouldn't be able to either if your brain was pushing you forward in the same way. But like we said, this isn't necessarily a bad thing. Plus, our work is showing that when adolescents are motivated, they are just as good as adults at lots of different lab tasks. So in these cases, their hypersensitivity towards rewards is having a beneficial effect on their behavior. The trick is to see how the unique configuration of the impulsive and reflective systems during the adolescent period can be used for good, to guide behaviors that will promote healthy development during this period.